Hi, I'm Julius, and my roommate accidentally killed a bunch of my plants, watering them incorrectly. And that's why now I want more than ever to automate my 3D printed hydroponic system. But before that, let's have a little recap on the last episode. Last time we started off with a 50 centimeter long tube and by drilling a hole in it. We did that using this type of drill, which is kind of a saw to drill large holes in objects. You can see this one right here has a diameter of 50 millimeters, so 5 centimeters. And this is exactly what the outer diameter of this cup right here is. So we use this thing to drill a hole, or actually 4 holes in the tube, and then use a file or a knife, you can take what you want, to cut in the eccentricity to get something elliptical. So that the couplings, or the cups right here, slide in at an angle of 45 degrees. After that, I showed you how to 3D print those cups right here to put on the plants. You can find the 3D model on Thingiverse. But now I want the plants that I've already planted in the tube to get watered and lighted automatically using a computer. And for that you need 2 components. The first one is the hardware or the circuit you build, which contains a computer, a lot of wires, and additional few components like LEDs and a pump. And on the other hand, you need the programming, using any programming language or whatever that you prefer. I used Python. But let's start out with the circuit. As you can see, the brain of the whole project is this Raspberry Pi 2, which controls everything you can see right here. Of course, you can take a computer from a different brand, like Arduino. If you don't think you need things like the date time, which is pretty useful for this project, you can of course also take a computer like the Raspberry Pi Pico, which only costs about €5, therefore is a bit more limited in what it can do. You can use for this thing in the programming sleep functions, like time sleep and then an amount of seconds instead of the date time you can use here. But more on the programming later. Anyways, the Raspberry Pi is connected right here to a 5 volts and right here with HDMI to the monitor, which is currently not plugged in. Then we have this few jumper cables right here from the GPIO pins. We have GPIO 2 for 5 volt input. No, not input, but 5 volts. And then GPIO 6 for 0 volts, so ground. You can see the 0 volt is here in this bar at the minus, and the 5 volts in the plus. From there on, you can see those 2 cables each, one blue one and a green one, blue and green, which are connected to the 5 volt inputs on these 2 relays. Relays, if you don't know them, are like electronical switches, so you can turn on and off the voltage for another, like for the lamps and for the water pump, using just 5 volts for maintaining the whole thing or whatever, and then 3.3 volts for controlling it. Then we get to the orange cables, which are, as I told you, the control or the input cables, and you connect them just to any GPIO pins with 3.3 volts that you can program as you want. I think I took 11 and 13 for the outputs or inputs for the relays. Output on the Raspberry and input on the 2 relays. You can see on this relay it's currently powered on because the lamps are glowing. Another important thing on the relays, you can see here are 3 ports for the cables, and the one in the middle is COM, and that is just the connection to to the both of the outer ones, which one of them is NC, so normally closed, and the other one is NO for normally open. So this way you can choose if you want the relay to be open or closed, if you have input or no input. I choose normally open, so just when there is power on those inputs, the circuit is closed. And then when the circuit is closed, as you can see here, the lights shine. Talking about the lights, here you can see them being connected through 5 volts, and then with those jumper cables, which is an interesting 3D print right here. So you can just connect jumper cables to a USB-A port. And you can also see those jumper cables aren't really reliable, but they are just for showing purposes. The other relay, this one right here, is connected to the pump, also with the normally opened version. And then to the programming, they are set closed every few minutes. Here you can see all 4 LEDs for all 4 plants being connected parallel, so that we can maintain the 5 volts from the plug minus the resistance of the cables and the LEDs itself, which then is about 3.3 volts, to power all the 4 LEDs, or if we want more of them, with let it be 0.5 ampere, because that one puts out 2 divided by 4 for all of the 4 lamps. We have 0.5 ampere. Here you can see one of the LED panels alone, and they are pretty cool and pretty bright, and you just solder them on 2 of those 4 plates. After we build the circuit, the whole thing can't do anything on its own. We then additionally need to program the computer so it knows what to do. And let's do that.
First of all, I don't know exactly what I'm doing either, but I'll do my best to show you what I've done here and also show you the problems. So in the first line, we have this import right here and then rpi.gpio as GPIO. This is just the pins we can program. And those are written in the following as just GPIO, so that is easier to write and understand. Then we need to import time as a constant, or that he knows what to do, what time is, and then also date time. Date time, as I told you, you can just use on the Raspberry Pi 2, but not on the Pi Pico, because it can't get this data for which date time it actually is. Then we have this task this task, and there the computer writes input, and if you write start, nothing happens, but then the following gets executed. I wrote that in this hashtag, and hashtag are just nodes and don't count. Then after that we have GPIO. So the GPIO board. GPIO means general purpose input output. That's just those pins on the Raspberry Pi, and from that there the board is programmed as the source or whatever. And then we set up the pin 11, they are all numbered, as output, and also we set up the pin 13 as an output. First for the lights and the second one for the pump. And then we create, or we have now as datetime now. So now right here is the variable, and datetime.now is from this datetime right here. And if you imported this, the computer knows what this is. Then I defined on and aus, which means on and off, um, is now dot replace, and then an hour, a minute, and a second, and a microsecond. You just have to insert that. And yeah, both for on and off, so that the computer knows when I'm writing an or aus in the following. I mean exactly this time, 15 o'clock or 14:25. And with the times, it's the problem on my computer that it don't actually uses the right time of the day. Indeed, it has a different time, so a local time or whatever. And so I took it different times for when the light and the pump should work, but you can do that just as you like. Then we define an action, which is motor on, and that for any pin you can insert here, which can be 11 or 13. In the following line, which is under define motor on, we have global on, so that the computer knows that now is a global variable and doesn't only get changed locally, but I don't know either how that works or how that helps. Then after that we have a while true loop, and under that an if loop with the conditions that now is smaller or the same as un, which is this time of the day, or now is smaller or the same as aus, which is this time of the day. Depending on which hours you want the light to shine, you have to change those signs and the times. But under that, we have the loop that I wish to be executed when while in this time of the day. The reason behind that is that I don't want the pump to run all the time, but just in intervals of 10 seconds and then a lot of time of doing nothing. Same, or not the same actually, but almost the same for the lamps. They shouldn't light or shine all the time because they could overheat. So they are like 800 seconds on and then 1200 seconds off. And that changes, or that starts all over there. And at the end of the loop, now gets updated to the current date time. So now is the actual current date time the computer thinks it is. And after that, just for indication, the computer should print out what now is. And then we already get to the problem of the code, which is that the computer doesn't know when to stop this loop. As an example, you hopefully know already how the system should work. So let it say from 20 o'clock in the evening until 7 or 8 in the morning, the system should be completely off. And from there on, this whole loop right here should work until 8 o'clock in the evening again, and then be off. And so on for every day. The problem right here is just that the system doesn't seem to know when the time isn't true already anymore. So if you power the system on, whilst the conditions for that are true, it fulfills the whole code, and whilst it isn't true, it doesn't. The problem is it can't switch between. I hope that after every running through one cycle, the code automatically would check if the condition is still true, and then decide if it should run the cycle again. But it doesn't seem to do that, and that's I think the only problem why the code doesn't work. If you know anything about Python or MicroPython, which is adjusted for the PyPico, you could please write it in the comments so we know what to do and the code can be updated. I will upload the code so you can see it and then change it as you want. However, in a world where the whole system would work, we then had to define the motor off for any pin which you want, and that is just the GPIO output for any pin. The pin and this pin must be the same, or automatically get set the same, gets low. So when we put motor off with pin 11 gets turned off or no energy. You instead of GPIO.low, you could also write 0 or 1 for GPIO.high. Then we have another while true loop, which if you just have true in here, gets continued forever, which I just made so that the conditions or that the if cycles right here get checked every time. First of all, we have if so on is smaller or the same as ours. The system should print a negative side interval, which means negative time interval, which means that the time the light is on is a negative time or just no time at all. So the system sends me a message to adjust that, please. We also have this if right here that now is bigger or same as un, or now is smaller and or the same as ours. Motor on 11 should be executed. So this whole motor on right here gets executed, which right here is defined only for motor on 11, but right here in 11, when you insert 11 right here, that also lets the cycle for the pump and the light work. Also, the system prints that the motor is on. The last cycle or if condition we have is now is smaller than un and now is bigger than ours. This is the time the motor should be off and no light and no pump should work. I have here in hashtag print motor off, which just should indicate that the motor is off, but I turned that off with the hashtag because it's sending a message every second 10 times or something. And then we have motor off 11 and motor off 13. Then we have time sleep 60, which should let this message send all 60 seconds because it gets sent every time the cycle right here gets run through.
So what's left to say? I hope any of you has any clue of Python. So please let me know if you have any solution for the problem so that we can make this code working. And please also share your experiences with this whole project, with the 3D model, with the code, with the circuit. And then I catch you in the next one.